Greetings from Dystopia, episode 23, the treadmill edition. More later. So, let me get this walk out of the way, and then I'll get set up for Raspberry Pi. Today we'll just do an overview of what it is and a comparison of Raspberry Pi to, say, an Arduino. And then we'll go from there. Alright, see you guys in a little bit. Hey folks, alright. So we are on the bench. For the purpose of our Raspberry Pi talk, you can find pretty much everything you need to know as far as the basics or things that I don't cover on the Raspberry Pi Foundation's website. It is raspberrypi.org. So I'm going to switch over to the camera here. For the purpose of our project here in general, I'm gonna work off of a Raspberry Pi 3 Model A+. It's what I have on hand the most quantity of, so we'll start there, but that's actually what we will be basing a project off of. To give you an example, I'll give you the lineup. So this is the standard Raspberry Pi 3 Model B+. This is a Raspberry Pi 0W. You can see the size difference. We're already getting down smaller. And this is the Raspberry Pi 3 Model A+. I have somewhat standardized on the A+ for some of my projects because, as you can see, the final project is significantly smaller. So again, we're going to compare the sizes side by side. The Raspberry Pi is around the size of a credit card. I do not have any card laying around to hold up there to give you a scale, but trust me, it's about the size of a credit card. Obviously, significantly thicker. The key features on the Raspberry Pi is integrated Wi-Fi. It has a ribbon cable display adapter, a ribbon cable camera adapter, which is this port right here, micro USB power input, HDMI output, audio out and audio in. So we rotate to the sides. We have an Ethernet adapter and 4 USB adapters. You have your GPIO, so this is your input-output header. It's a series of pins to which you connect wires to move on to your additional peripherals. For the functions of using this as simply a desktop computer, if that's what you want to do, the main things you're going to worry about are your power, your video, your audio, network, and then your USB peripherals attached here. So that would be it set up in its basic computer function. They do come, there are plenty of cases. I have several over here we can go through on another video, but right now I'm just talking about the difference in the cameras. I mean in the, sorry, in the Raspberry Pis themselves. I mentioned that I have kind of standardized on the Model A+, and that's because a lot of my projects, I don't really need Ethernet. I don't really need to be able to come up and plug in a network cable. I really don't need that because I just need wireless access to reach it. So what they have done with the A+ is they have, as we put them side by side, you can kind of see they have stripped off Ethernet and 3 of the 4 USB ports. So you're left with a single USB port. You still have the same GPIO header on both cards. You still have the display output and you still have the camera output. Really, you're just losing network and 3 USB ports. But again, like for the car computer, I don't need Ethernet. I only need 1 USB in practice because my GPS system actually connects by Bluetooth to the device. So the USB is really only for HMI, a human machine interface. So I use the display and the HMI and the USB for keyboard and mouse combination. We'll talk about that as we get down the road. But if you're building something ridiculously small and do not need a lot of power, then we have the Raspberry Pi Zero W, the wireless version. Still has the same micro SD connector as I try to pull a micro SD out of an adapter. So all three utilize the micro SD card for storage. So your operating system and everything is stored on the micro SD. There are many more hacks coming out. I'm sure soon we will see a lot. I just recently saw a SATA or SATA top hat. So a top hat is any device that plugs in to the GPIO and stacks vertically on top of the board. So this is kind of I'm just making a model of it, but it would stack on top of this. And the one that I just recently saw has 4 SATA ports, and so it's 1, 2, 3, 4, and then has power in. The idea of that is to build your own NAS, or network attached storage, with vertically mounted drives. That might be a project down the road, just for the fun of it. But yeah, so the Zero W again is about the size of a stick of gum. It is wireless. It contains micro HDMI, 2 micro USBs, 1 for power, 1 for communications. It still has the camera header, I believe that one is, or is that the display header? Actually, I think that's the camera header only on the Zero W. So I've never used it with a camera. To me, I actually use these for network bandwidth monitoring. There's a lot of cool projects you can do with these because they have the full I/O. You would just need to solder in so you would insert your pin, as needed. You would insert your pins and solder them in place on the back of the board. Or you can actually solder in an edge connector like this type back onto the board. You can also buy the Zero with the header pre-soldered. It's not from the Pi Foundation. They're done by third parties, but there's not much that can be messed up. If you're not good at soldering, you might want to stick with buying it with the header on it. But yeah, so so for our project, we'll take the 3A out of, we'll stick with what you're going to get probably from Amazon. And we'll just stick with the 3B Plus. So we'll do a project using the 3B Plus. Just to kind of simplify things as far as discussing the capabilities, processor size, memory size is going to vary between the two. But the 3A Plus is the one I know the best because it's the one I use the most. The 3A Plus is a 1.4 gigahertz 64-bit quad-core AMD Cortex. It uses the Broadcom, so it's actually an ARM CPU if you're not familiar with that. It has 512 megabytes of SD RAM. It has a dual, so it has the dual band 802.11a and C, wireless LAN, and Bluetooth 48. It is BLE, low emission Bluetooth. It has much faster USB booting off of the mass storage. It's funny to say that it's mass storage, but I think in terms of terabytes and petabytes for mass storage, not in the case of this micro SD 200 gigabytes. It has a single USB port, standard full-size HDMI. This is a USB 2.0 port. It has the standard CSI camera port and the standard DSI display port. 4-pole stereo audio, so left and right. It also has a composite video output on this port with the correct adapter. The micro SD is located on the back, and that's for your operating system and where data is stored. You can also store externally to USB devices, so USB thumb drive, USB hard drive. Warning on USB hard drives: ensure that you do not exceed your input power capability on the micro USB. If you use external USB drives, it has to be either an extremely low current draw solid state drive or an externally powered USB drive. You've all seen various USB devices. This is a case that I have a 250 gigabyte SSD in. This is, we'll say, leech powered. It draws power from this device. If you wish to use one, make sure it's solid state, very low current design, or it is a USB connection with an external power supply that you would plug into it, just to ensure that you do not overload the port on the Raspberry Pi or your power supply itself. I'm going to plug that back in so I don't lose the connection. But we'll go into a lot of that in much more detail as time goes down the road. The power input requirement for the 3A Plus is 5 volts at 2.5 amps DC. I guess I should have turned it back that way so you can actually read it. I will apologize for the video size here on the screen as I try to get my fingers in here. This is actually my first time using OBS Studio, and I'm having an issue getting the webcam to full-size display. So I'll show you. If I switch over to pi.org, you're now at the full width of the screen. However, the webcam is a significantly smaller view. I will figure that out, hopefully before the next video. I was asked when I talked about these to discuss the difference between the Raspberry Pi and the Arduino platform. And yes, I'm using a chopstick as a pointer. Let me grab a drink here if you don't mind. So they're two quite different boards and two for completely different purposes. Each has its advantage. It just depends on the project. The first thing we have to talk about actually is the devices themselves. So the Arduino was invented by Massimo Benzi in Italy. It's designed as a simple hardware prototyping tool. So what their intent was that you would take the Arduino, hook up either digital or analog inputs, external power comes through there, and then expand onto a breadboard. So you would bring your digital or your analog ports across, design your prototype using whatever electronic components you need as I reach out for bags, and you would build the prototype on the breadboard, design it. When you've completed the project, completed your programming, the Atmega 328P chip, this is actually the microcontroller. The rest of this is what's designed to extend the pins on this controller out to the real world. You prototype onto the board. When you've completed that, you come up with your circuit design. You use an external software program to design your circuit board. Some people are still hardcore and they draw it. But by doing that, you can actually have a custom circuit board created to which you would mount your own Atmega microcontroller onto that circuit board, and you would essentially build a custom board with the only outputs on it and inputs on it being exactly what you need for your project, and that's it. So that was the original intent, was to design projects around this particular microcontroller on a breadboard and then build your own custom circuit board. It's kind of an oversimplification, but it, you know, the rule of thumb stands. That was the original intent. The Raspberry Pi was invented by, I think it's pronounced Eben or Eben Upton at the University of Cambridge in the UK. And the idea was for K-12 programming skills, to teach them basic programming of microcomputers. Microcomputer is your desktop at home, your laptop. Those are what's considered microcomputer category. They are both extremely suitable tools for beginners and hobbyists. Don't be afraid of it because, oh wow, I can see all of the individual components in the circuits. Don't think of it that way. This is a computer. If, you know, once you get it built to a certain extent, you're going to turn around and you're going to mount it in a case. Once it's in the case, it becomes covered up. It's a computer with your I/O, all of your ports, and that's it. So you're back down to a computer in a box. If you have ever built your own computer, you got this. Don't worry about it. The main difference between the two, again, is the Arduino is a microcontroller, while the Raspberry Pi is actually a mini computer. You could think of it as an Arduino is part of a Raspberry Pi, because a Raspberry Pi contains microcontroller functions as well as a standard processor, standard software load. Raspberry Pi is good at software applications, whereas the Arduino makes hardware projects simpler. And that's where you start to see the overlap between the two. Again, software controlled with microcontroller capabilities, microcontroller only. Right off the bat, your first thought is, well, then why don't I just use this? You probably can. We'll talk about how that expands out a little bit from there. Again, the Raspberry Pi is a mini computer. So as we go back over, the Raspberry Pi can run multiple programs at a single time. The Arduino, being a microcontroller, which is only a sub-part of the computer itself, can only run one program over and over and over again. Power requirements. Raspberry Pi is difficult to power using a battery pack. You can, don't take that as the gospel, but the power consumption is significantly higher on a Raspberry Pi. The Arduino you can power with a simple battery pack for multitudes of hours and days, depending on the capacity. Again, same applies here on the Raspberry Pi, but it's a much higher power requirement. You just went from a battery that's roughly the size of the Arduino to the battery that's the size of a car battery to power the two of them for the same amount of time. The Raspberry Pi, as you start to move on with it, does require more, I don't want to overstate this, but it does require complex skills, complex tasks, which are all things that you'll learn. They're very simple, but installing libraries and software for interfacing with sensors and etc. through the GPIO pins are a little more difficult on the Raspberry Pi. It's not impossible. There are enough step-by-step instructions on the web. Believe me, if you have basic computer skills, you can do this. It's very simple to interface sensors and other electronic components with Arduino. The libraries are already included through the development interface, which we'll talk about at another point down the road. Raspberry Pi, typically about $35, $25 to $35. They get even cheaper when you start talking about the Zero, which is about $5 to $10, depending on the config. Arduinos typically start at around $10 to $12. Trust me, if you buy just the chip and you opt to prototype the whole thing. If you already have a prototyping board, you're in it for just $1 something. So Arduino in that case wins hands down if you just need a microcontroller for a project. The Raspberry Pi can be very easily connected to the outside world via its Ethernet port, via USB ports, external USB Wi-Fi dongles, serial communications. In this case, this one has Wi-Fi built into it. Whereas the Arduino requires a ton, not necessarily a ton, but external hardware to connect to the internet, because it needs to be addressed in code. It needs to be attached as a serial device through the transmit and receive ports. It gets a little bit more complex. Now, as with everything else, there are exceptions to the rule. Similar grade microcontroller, however much smaller, this one includes integrated Wi-Fi. This is a whole different type of controller. We can kind of move down to that as we go through time. The Raspberry Pi does not have onboard storage. The storage in this case is handled again through a micro USB card, or I'm sorry, a micro SD card plugged into the micro SD port. You've all seen this port on cameras, cell phones. A lot of laptops now include them. I know all of my laptops have micro SD ports on them. So you've all seen this chip in your camera, in your phone, in your laptop. You've all seen that micro SD before. The storage on Arduinos is a little sketchy, and it varies between models. Typically 16 to 32K. I've seen several larger versions now. There are also prototyping boards available with micro SD or full-size SD capability. So it varies. Sticking with input-output to the rest of the world, the Raspberry Pi in most cases has 4 ports. As I showed you earlier, the A+ has a single USB port. Arduino has only one USB port, and that's used to connect to a computer for programming. Again, as with everything else, there are exceptions to the rule. This is another converter, and what I use these for is the systems that I've built where I've used just the microcontroller itself soldered into a custom designed board. I use a USB serial I/O adapter. Trying to make sure that comes through, but here's your micro USB cable, the serial adapter chipset, and then this plugs into the board, the custom boards that I've designed. This can be soldered in place and bent over so it's part of the board, or soldered in, program the chip once, remove the board, the I/O board, so it just prevents somebody from modifying programs in the future. There's lots of reasons for that. I don't need to go into that, I don't think, for explanation as to why you would do that. Raspberry Pi uses a ARM processor, from the ARM family of processors up to a quad core. The processor used in Arduino is actually an AVR processor, better known as the Atmega 328P, which is this board right here. Capacitors, reference crystal for speed. This I/O chipset, it's you don't have to worry about a lot of this stuff for the basics of what we're going to do. Another major variant or thing to keep in mind if you're deciding on which one of these to use for a project. The Raspberry Pi does not do well losing power. In fact, if power can be just taken away, there is a good chance that you stand of corrupting the data that you're storing. So any data that you've logged to the chip or your operating system can very easily be crashed. So it's a good idea to actually have 2 micro SDs. The better option is, and we'll talk about that down the road, is just to write a script. And the script runs as a cron job, so it's running all the time intermittently, every half a second, every second, depending on how you choose to time it. And you hook up a switch onto the board, and it's similar to a power switch on a computer. You hit it, so you would wire it in, run the script through a cron job, push the button, and you will watch the LEDs go as it cycles down, writes to the micro SD card, and then shuts down properly. The Arduino doesn't care. If the Arduino loses power, oh, okay, I lost power. The second you power it back up, it loads back up the one and only program it runs and starts working again. So it just continually runs. You unplug it, it stops. You plug it in, it runs. Not so with the Raspberry Pi. Programming languages. This is the part that scares the hell out of everybody. Don't worry about it. We'll go over it as we get more into it. Recommending programming languages on Raspberry Pi is Python. However, C, C++, Python, Ruby are all pre-installed as part of Raspbian or the Noobs operating system. There are tons of other IDE, so integrated development environments, that you can install if you only know one particular language to work your way across. There's also ones that are aimed at children that it's a modular programming interface, and it's visually, if you think about putting together a puzzle, that's essentially what the kids are doing, is they're dragging and dropping in these different parts of a program and adding little snippets of code to those puzzle pieces to build the functional project. We'll go over that when we get to that point. Arduino uses its own development environment, C or C++. Again, there are exceptions as you move out of the Arduino space into more conventional microcontrollers. One of the latest ones is MicroPython. So some of the other controllers, oh, where is my one that's out of the bag? There it is. So some of, like this type of controller, the 8266 series and etc., are actually capable of installing MicroPython on them. This one has a Wi-Fi interface, so you can connect to it over Wi-Fi through a web browser and actually adjust your program that way without having to remove the project via micro USB. But this is way beyond the scope of what we're doing now. So yeah, so we will move back and we will just work through our project with our Raspberry Pi. It's kind of up to you guys. You need to tell me what type of project you want to work on. I know 2 of you said that you had breadboards. So for those of you who do want to follow along and don't have a breadboard, there's a ton of breadboard kits that come with the resistors, headers, tie cables, LEDs, various capacitors, speakers, switches, piezo, beepers. So I think maybe we might want to just decide on a project. That's a good one. I had talked about my car computer that I was working on for GPS mapping, which I have actually disassembled because that is what the 3A Plus is out of. To give you an idea, so I reboxed everything. As much as I am violating my own rule. So my car computer project, which I had mentioned, was mounted in a carrier frame. So this is the control for a 7-inch LCD touchscreen. The computer, the Raspberry Pi itself, was mounted on the back of here, and this is mounted into a case. So everything on the user interface is right here. Sorry. Oh, there I am. So everything on the user interface is driven by a touchscreen. It's something you guys all are familiar with by using your phones. But I also had several external buttons. One of them was, as I was talking about, is a restart or a shutdown. All done by script, but they were external buttons. So yeah, there's a lot of things you can do. So maybe we should figure out a project. I will leave that up to you guys to help me decide on a project. All right, that's it. That's the end of today. We will end on this note right here. All right, guys, that's it. We'll catch you tomorrow. Hey, folks, hopefully that wasn't too much for you. Tried to just cover the basics as well as I could. As you can see, I'm in final edit waiting on this video piece. Again, let me know the questions you have, the things you need to know, want to know, and let's talk about below a project. I think the car computer is well within the grasp of everybody that has basic working knowledge of computers. Like I said, if you've ever built your own computer, this is something you can definitely do. But again, it's up to you guys to drive the channel. Tell me what you want to work on. That's it. Be good. Be well. See you guys tomorrow.